Okay, so today we will try to solve this exercise, which is exercise 3.1 from this book, which is Dynamic Static Made Simple. Okay, exercise 3.1. So the question said the system shown in the figure is in equilibrium. Okay, so the word is in equilibrium. So the question asks to determine the first one, tension in cable AB and also BC. And then the second one is the mass M. So we have here three unknown, tension AB, BC, and also the mass M, three unknown. Okay, also, of course, the answer is already given, but I just want to show you how you got this answer. Okay, so draw, which is, okay. So the first thing to do is you must draw a free body diagram. So now we want to know the tension AB, BC, and the mass. So of course, the point of our analysis will be at point B. So the first step is to detach the point B from other parts and analyze this point. So we take this point, which is the point B. Okay, so make it other color. Is the other color? This one. Okay, so point B, draw free body diagram. Okay, so now you have this point B, so put it away. The first thing to draw in free body diagram is you have to put the external forces. In this case, we don't have external forces. The second step is to find the cable. Now we have three cable, which is BC, AB, and the one that hold the mass M. So we put that as cable. You need to remember that all the cable must always acting outward of the component. It is always in intention. So we have the first one is going this way. Just name it as it is, TBC. So the angle here is given 30 degree. And then TAB is this way. Name it as TAB. Angle given as 45 degree. And then the last one is going downward M. Okay, which is if we want to put everything in Newton, of course the T is Newton, so the M must be converted into Newton. So we put it M times G. The weight of the component will be mg, all in Newton. Okay, so now we have the free body diagram. Okay, the first step, detach the component, put the external forces, and then put the cable. And if the component have mass, we put mg downward, and the last one is the reaction force. Here we don't have any reaction force. Okay, after that we have to come up with the equation, which is in equilibrium sigma f equal to 0. So from this equation you make a table just to verify all the components. So we have, where is it going? So here. So you should have, first is T A B plus TBC, which is plus mg equal to 0. Okay, so of course it is a vector unit. It's not you have to add it accordingly. So you should have here, check for the unknown. So you have now TAB, which is your unknown, first unknown. The angle is known, this direction 45 degree. TBC is also another unknown. Angle is there, which is 30 degree. mg is the one that you know, you also unknown, which is m is m times 9.81. So direction is downward. Okay, so even though from here you can see that, okay, so from here you can see that you have actually here you have actually 1, 2, and 3 unknown. Okay, you have actually 3 unknown for only one type of equation, which is later on you will resolve into x and y. So you have 2 equations. So 2 equation, it is difficult for you to solve 2 unknown. But if you look at the other part, which is point C, this cable is actually linked to the mass 150 kilogram, meaning that the tension in the cable that hold 150 kilogram is the same tension as the TBC. Okay, one tension, one cable goes through pulley will have one same tension. So, in other words, we should know that here the TBC equal to 150 times 9.81 Newton. 9.1, the unit is in Newton. So from there we know actually the TBC is same as the mass of that 150 kilos. So you calculate that one. So you have 150 times 9.81. So the TBC is actually 1471.5 Newton, which is same as given in the answer here. So you replace this TBC here. So I want to replace the TBC. Erase. So I will erase this part. So the TBC is actually 1471.5 Newton. Okay, so by doing so, I now only have 2 unknown. Okay, so 2 unknown for this type of equation, so we can easily solve this equation. Okay, so we have several methods. The one that I will show here is rectangular component, which you need to resolve everything into x and y direction. So now I want to resolve this one. So of course, I have this is TABY, this is TABX, TBCY, TBCX. This one is only in y direction, so x equal to 0. Okay, and then so let's solve this one by one. We can choose either to solve in x direction first or y direction first. Looking from this equation, it is of course easier for you to solve in x, because y here is the component of ng in x is already 0. So you solve in x first. Let's go. We have this one. So you have choose one direction as your positive direction. Sigma fx equal to 0. So you have TAB, which goes to the left. So you'll be negative. Negative TAB cos 45 plus 1471.5 cos 30 plus 0 equal to 0. So from here, you can have directly the value of TAB, which is equal to, so just calculate here, put the TAB the other way, you can have positive value. So 1471.5 cos 30, you should have 1274, and then divided by cos 45, which is from TAB, you have 1802.2 Newton, which is same as here, the answer given here. Okay, so now we have already solved 2 parts, which is TAB and also TBC. The rest is the M from here. So the M can be solved in y direction. So we go to this way. Positive sigma Fy equal to 0. Okay, sigma Fy equal to 0. Now we know the TAB, which is 1802.2 sine 45, positive because it is going upward, same as our direction positive, plus 1471.5 sine 30 minus 9.81 m equal to 0. Okay, put it the other way, you can have the m equal to. Okay, so just calculate this one. 1802.2 and then sine 45 plus 1471.5 sine 30 equal to divided by 9.81, so you have 204.9 kg. Of course the unit is kg because we have divided by the 9.81 the acceleration. So same here, you got the answer as given here in this part. Okay, the m equal to 204.9 kilo. So that's it how you solve this equation. First you draw the free body diagram, and then you look at for the unknown. If it is more than 2, you have to find from somewhere else. You need to remember one cable goes through pulley will give you same tension. Okay, and then after that, once you sure it is only leave you only one unknown, so you have to solve sigma fx equal to 0, sigma fy equal to 0. If needed, you need to use the simultaneous equation. In this case, we don't have to use because one of it is already 0 in x direction. Okay, so thank you for okay, so that's it for today. Thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.